Hi friends, in today's video we will be having a quick session on data analysis using R. So firstly you will actually need to install the R Studio. So what you can do, you can actually go ahead on say browser and then type download say R. So firstly you have to install R and then you will actually install R Studio so that the R Studio actually detects R which is actually installed on your system. So from this particular link, which is from the cran.r project, you can actually go for the first thing if you are on the Windows, and similarly for the other platforms. So you can actually go for the Windows one. You will actually get a setup. You have to go next and install. This will install R on your system. Then actually you can type for R Studio download, right? In this fashion, you can actually go for the links. There's a link from Post-it that says download R Studio. And if you actually go down, you can actually go for the download R Studio. Then it will actually take up to the next page from where you can go for this link that is download R Studio desktop for Windows. After you will actually install the R Studio, you can search for R Studio from the search bar, or if it's actually creating a shortcut, you can click that. The R Studio will open up and will show you a command, say prompt, in which it will show that automatically detect R in such a fashion. It will detect the R which was already installed in your system. So now for the today's session, what we will do is we'll actually use the basic libraries in R to actually have some plots and get some insight and analyze one of the datasets which is actually available through this package for the penguins. So this is a Penguin dataset which we will be actually using in today's session. And let me actually clear out everything so that I can actually show you everything from start. So firstly, let me get you familiar with the R's interface. From here, if you actually go for the file, you can actually go for the new file and then R script. And in such a fashion, the R script will actually open up a new file in which you can write R script, right? Like Python, you can write the languages here, like you can write commands, whatever you want to do, right? This is the terminal of R in which, or you can say console of R, in which you can type the things out and you can run the commands directly from here. Whatever you will write, for example, say install and something, install the packages, right? And you can actually mention some sort of say package like read.csv, something like, or different package, right? You can type in here, and then you can do is select that particular stuff and click on run, right? That's what you need to do to actually run a command. This is the data section in which some of the environment, some of the variables which you create will be here, right? For example, if you import the data set, right, then the data set will be imported in the variables here. For example, I've already imported the penguin, and you will get to see the data set by clicking on the penguin, right? So what I will do is that these are the ones, right? And then I will actually free the data set, right? So yeah, so all the objects will be removed by using this button. Now this section is very handy while coming to install packages. So you can actually go for the packages and you can search for some of the packages like ggplot, right? So there's some package you can actually hit the tick icon to install the particular package if you want to install through the user friendly interface. And if you want to install through the command, then you can obviously do install.packages. So remember, while installing a package, you just need to type the name and install.packages. Inside the bracket, just type the name, for example, say ggplot2, right? And then I will actually just select all of this stuff and click run, right? So ggplot2.run, basically it's already installed. What is that? ggplot2. Yeah, basically I've already installed that particular package while actually doing this one, right? So okay, so we need to actually type in the strings, right? So essentially if you have created a variable and then did this, then this must have if you actually go for this one, then yeah, it will say okay, so your R Studio is gonna install this one, and yeah, it will actually try to install the particular package by downloading to dot, right? But this package is already installed into my system, so it will do nothing other than just rescanning all the stuffs and then trying to install the things out, right? Okay, so what is the today's flow, right? We'll actually have a look at the penguins dataset, which is available in the Palmer penguins package. So like other packages, we will be actually using this package, right? That is install the packages, and then we will supply in string the Palmer penguin. So let's actually run this particular command, right? Select and then click run, right? And also you need to be connected to internet to actually download the packages, because it actually finds the packages online like the PIP does in Python. So yeah, after downloading, it will show the downloaded packages are inside this particular directory, as Python does it for the site.packages folder, right? And after you have installed the packages, you might need to import the packages before using it. So in the Python, we used to do import and that particular package name and then add. But here, what we do is that we'll use library function, and inside it, we supply the name of the package which we want to import. Our package name is Palmer Penguins, and if we select this whole line and then click on run, then it will import this particular one in our environment, right? Now the data function will give us the particular data from this particular penguins, right? So you're gonna use the data of the penguins. So from this library, I'm gonna use the data. So I will actually select this particular command and click on run, right? So after you actually run this particular command, your data will be available to the environment. And for example, you have this penguin, right, and also penguins raw, right? So inside this penguins, you can have a look that this is the particular data set which you have, and for this you have used the data function, right? So basically species is one of the column which is actually mentioning some of the species of the penguins. Similarly, there are islands, right, for the penguins, and then you have the bill length, then bill depth, and flipper length, and flipper, then you have the body mass, ear, and all, right? So these are all the columns which are available in this Penguin dataset, and we will be actually becoming detective and try to find out the insights from this dataset using the simple plots. So if you want to have a look at some of the rows from this Penguin dataset, what you can do is you can use head. You might have also seen head function in the pandas data frame, right, which was looking at first 5 rows or last 5 rows of the data frame, right? The last 5 rows was used using the tail, and the head function actually get us the first 5 rows. In this RStudio also, right, we have head function which will give us the first 5 rows. If we run this one, the outputs will be always available in the console here, right? You can resize this console, right? So it will also show you that which command has been run, right? Head of penguins. You can also type this command directly here in the console and then run this the particular output, right? You can have some of the initial rows of this particular data set by looking at here, right? Like what head do in the Python. Now, so we will actually try to find out these things in the data set, that whether different penguin species have different flipper lengths, whether it is the case with the current data set. And how does the body mass actually varies across different islands? Means if the island changes, how the body mass is actually vary. And can we actually make some graphical plots from which we can get this particular insights very easily? We will do some sort of plotting, right? So firstly, before going further, let's actually have a look at whether some of the penguin was not able to report some of the results, right? Whether some of the penguins missed its body mass, whether some penguin missed to enter their flipper length, right? So we can do that with the summary function, right? In the pandas data frame also in Python, you might whoever has done coding with Python might already know that there is a function named summarize in the data frame that summarizes all the counts of the non-available items and other counts like min, max, and all in Python. Similarly, the summary here in the R will actually give us the summary of all those stuffs, right? Like you can see the species, it will show there are 3 species: Adelie, Chinstrap, Gentoo, right? And these are the number of items in those, mean number of sample of those species. You can see that this is the imbalanced dataset, so you might need to do some upsampling or say downsampling based on your problem statement, right, for the dataset. In the islands, we have 3 names, right? And then for the bill length, it's actually a numeric column, so it's actually giving us the min, median, and mean, and the max values. And there are 2 NA values. There we have 2 NA values. Here we have 2 NA values. Here we also have 2, right? So in this fashion, you can actually get an insight that how many values are not available in the dataset, and you can process accordingly. But for the today's session, is actually a beginner session, so we'll actually ignore this stuff and we'll actually do that in the later videos. For plotting, there is a plot named ggplot2, as I've already shown you here, right? So what you can do is that you can just go ahead with this command, that is install.packages ggplot2, and then click run, right? In the command prompt in the console, you will see that it's actually trying to communicate to different URLs and trying to get this particular package, right? and it's downloaded the package, right? And also install this particular package, right? So yeah, this is what it is doing, right? After installing, you already know that how to use this package. You need to import this package, and for importing we have library function again, and inside it we will supply ggplot2 as it is. Just mention one thing, that while installing you need to supply in the string, but while importing you need to supply directly the particular package name. So we will actually run this, and this package is available to you. We can now use ggplot2, right? Okay, so now we need to plot some sort of graph. So what was our first question? Our first question was that flipper length by species, means we need to find the flipper length by the species, that which species has which sort of flipper length, right, in whatever the metric they have mentioned. So we'll actually try to plot a box plot here, right? Box plots actually gives you the range, that how many of those the species are actually outliers, have a outrageously different flipper length, and how many of them are actually in range, what is the mean of all the flipper length. These all information is actually given by box plot. So before actually making you understand this particular command, I will run this particular command, right? So I will actually run, and here you can see a beautiful plot is actually getting created. You can actually resize this up, and all the plot will be adjusted dynamically, and that's the special feature which I really like, other than Python, in R, that all the plots you can adjust, right, according to different size, right? And you can actually have a different graph generated dynamically. You can also export this particular graph and save as an image in your directory, right? You can save this particular graph, right, and hit save, right? So it will actually be saved on your computer, right? You can use that on your research papers or whatever way you want, right? Now let's try to understand what is it actually showing. It's showing you that Adelie was a species, right, which is actually having the flipper length from say mean around 190 and going towards this to this, right? So boxplot actually shows you quartiles, that how where the 25% data lies and where 75% data lies, and what are the min and the max, right? So in this particular state, in this particular case, that where the Adelie is there, you have say minimum somewhat here, maximum somewhat here, and then you have the 25 percentile data lies around this much of length, and 75% data lies around this much of length, and this is the mean, means this is the median value, right? And similarly, these dots are actually expressing the outliers, right? What are those particular penguins which have really large flipper length and very small flipper length. So these are there. In the chin strap also you have this sort of say box plot, which is actually a bit higher, and in the Gen 2 species you have a comparatively larger flipper length. So you can directly get insights by looking at the box plot of this particular species. So how to actually make this box plot? We know that we need the species on the x-axis. We know that we need the flipper length on the y-axis, right? And what is the data we have? We have the penguins data set, right? Because we have imported the data into the variable name penguins, right? So this is how the data was imported. So we will use that directly. So the penguins will be supplied in the ggplot function as the first thing, right? So what ggplot we do is actually create a blank plot for you. First parameter is actually which data you are actually working on. So we have this penguins data set. Then we have the AES. AES stands for aesthetics, like how you want your graph to look like. So you have the AES, and then X is actually given to be the value of species. Y is actually given to be the value of say flipper length mm, right? So if you actually have a look at the data set right here, flipper length mm was the name of the column, right? And species was the name of the column of the species respectively, right? So you will supply the exact column name here, like x is equal to species and y is equal to flipper length mm, and then you will actually give species, right? Means the color will be actually filled on the basis of species, right? So it will take up the colors, 3 different colors according to the different species, and fill up in the box plots, right? So this is what aesthetic line is actually doing. Now we will close up this ggplot, right? Now till yet you have not told that you want to actually make a box plot. So what this plus is actually saying is that stack different instructions together, right? So what you are doing is that you are just calling out this ggplot once, and then you are calling, okay, hey, I have given you the information of x and y. Now you need to also take into consideration that you want to plot a box plot. So what you will be actually doing is that GOM box plot. This is the function which you will be calling to actually plot a box plot, right, with this data set and information which you have provided. And you also want to give the labels, right, to this particular graph. So you will actually supply another plus and then labs function. labels, right? Labs function, in which you will supply title equals to flipper length by penguin spaces. That's actually the title. Then you have the x equal to spaces and y is equal to flipper length right? So the x-axis will have the legend, or you can say x-axis will have the label of the spaces, and y-axis will have the label of the flipper length and bracket whatever you want. Okay, you will actually see here, right? And then again, this command will be actually stopped, means this function will actually be closed by another bracket, and after that you are supplying another plus, which is saying, okay, I want to also mention something else, right? So we are mentioning theme minimal, right? In the default theme, you will actually find a lot of grids actually coming out here. So theme minimal will actually come out, will be actually giving you a different theme that is actually lighter and simplistic theme, right? There are different themes available in the R, like dark one also, and also another one, right? Which will actually give you more modification over the plots which you are having, right? So our one question is actually answered. Yes, we are able to compare the different flipper length among the different species from the data set. Now what we want to do is that we want to get the body mass by islands, right? Means what we want is that, let me actually show you. If I actually plot this particular command, right, it will actually give us a different graph, right? Obviously. Now what we are seeing is that we want the particular islands to be on the x-axis, right? We want the particular islands to be on the x-axis, and for those islands we want the body masses of the different species, not one species. We want the body masses of the different species, right? And we also want that different species need to be colored according to the species names, right? So for example, the Adelia species is colored to be red, and chinstrap is colored to be say green, and the Gentoo is colored to be say blue, right? So in this fashion, how to create this one? So we'll again create a blank plot. So for that we will use the ggplot function. Again, we will be actually supplying the penguins dataset. That was the dataset which we are working on, and then in the aesthetics we will try to provide the x-axis, y-axis, and how do you color the different things up. So x-axis, as we know, is the island, right? Y-axis is actually the body mass G. So if you actually look at the dataset right here, from which you will actually get by clicking this penguins variable from the environment section, right? And then we have the body mass column to be body underscore mass underscore G. So that's actually what we are supplying here, right? So the y-axis will be body underscore mass underscore G, and then you have the color to be taken from the species column, right? So this is directed, okay, you need to create a new plot with these of specification, but which type of plot you need to create? So what you need to do, you must remember, you must apply a plus, right, which is followed by the geom point. This is another function which will actually plot the scatter plot in RStudio, right? So geom plot, before it was geom box plot for the box plot, and then we have the geom underscore point for the scatter plot, right? Here we are supplying additional parameters like size equals to 3. If I actually supply the size equal to 1, that is actually the default one, then you will see the scatter plot to be having very small circles, right? But we want a bit larger, so we are supplying the 3 as a parameter. So if you actually run this one, then the circles are a bit bigger. And also this alpha, you might already guess, right? You might have already guessed that it is for the transparency. So if you supply like say 0.2, then they will be even more transparent, and while going towards 1, they will actually become more opaque. This is pretty much useful in the cases when you have overlapping circles and you want to have a look at all of those, right? Now you have the labs. Now you will tell me that what this labs function will do. Yes, this particular function will do what is actually supply the labels here in the graph. That is, the title is actually for the body mass by island, right? And x-axis will be actually given the name of island, and the y-axis will be actually given the name of body mass G, right? And then again we are supplying a theme minimal, right, to actually give it a minimalistic feel. You can always save this graph by clicking this export, right, or using the command, right? So now you are actually already done with the basic tutorial on R. You can actually do more complex stuff with the R, right, by taking up your own dataset from the Kaggle and then reading up the dataset, right? This was from the library, but you can also read your own CSV based dataset by using the read.csv function, right? This is the function which will actually read the particular file, right? You can already see in the help, right? So firstly it will actually get the file name, that which file you are actually wanting to read, and then there are other parameters which will actually process the file as according to the type of file. For example, if the separator is not comma, it is a tab separated list, so you will supply the tab. And similarly, there are different options available according to the file. So that was all for this R Studio tutorial. Hope you like it. Like and subscribe, and I will actually come out with more interesting videos in the future sessions. Thank you so much.